Hello there. So we'll be looking at section B of the Further Mathematics WAEC questions for 2025. Part 1 is pure mathematics. 9a, given that the integral within the limit negative 1 to m 2x squared minus x minus 3 close bracket dx is equals to minus 9 over 2. The question asks us to find m, so we are required to find m with the condition that m is an integer. So m is an integer solution. So let's proceed to integrate that first. Okay, so we see that this becomes, I will integrate right away. This will give me 2x raised to power 2 plus 1 over 2 plus 1 minus x raised to power 1 plus 1 over 1 plus 1 minus 3x plus c, of course. Then this is a definite integral. We have negative 1 and we have m. Now this gives us equals to 2x raised to power 3 over 3 minus x squared over 2 minus 3x plus c. C is our constant of integration. C is our constant of integration, which will disappear the moment we substitute these limits of integration. Okay, so let's get right into that. So I'm going to have to substitute the upper limit, that is 2m raised to power 3 divided by 3. Let's write that properly, minus m squared over 2 minus 3m. Okay, this is the upper limit, minus, we now have, when we substitute negative 1 into this expression here, it's going to be 2 minus 1 raised to power 3. So that will end up being minus 2 over 3. We substitute minus 1 square will give us minus 1 over 2. Minus 3 minus 1. As we see, constant of integration disappears in that question. Okay. Now let's see what we have here. Now I would like to solve this very fast. I see that the denominator here, we have 3, 2, and we have 1. The same thing here. So I'm going to solve them separately. The LCM of the denominators is 6. So let's multiply through by 6. If we do that for the first expression, so that becomes 6. If we do that for the first expression, so that becomes like this. We're going to have the denominator here is 6. Good. Now 3 into 6 gives us, we know the drill, that becomes 2 times 2. I'm going to have 4m cubed. Okay, minus 2 into 6 is 3 times the numerator. I'm going to have 3m squared. Okay, minus 1 into 6 is 6. 6 times minus 3m gives us minus 18m. So basically what we are doing here is just simplifying this fraction. So we do the same thing for this part. Okay, so this gives us LCM remains 6. So 3 into 6 gives us 2. This becomes minus 4. Okay, then 2 into 6 is 3. This becomes minus 3. and this becomes plus 18, because 1 into 6 is 6, minus 3 times minus 1, we come out as positive 3. So that's what is there in the numerator, and this gives us plus 18. So we can now collect our like. Let's see what we have here. Now this implies, I would like to factor out 1 over 6 for simplicity. So this becomes 4m cubed minus 3m squared minus 18m. Okay, then we have here minus 4 minus 3 plus 18. Now minus 4 minus 3 will give us minus 7. Minus 7 plus 18 gives us plus 11. Okay, so the entire expression here evaluates to, let me clarify that, everything here evaluates to plus 11. Now we need to open it up with the negative we have here. Minus times plus makes that expression to end up as minus 11. Now let's not forget we have a right hand side. Everything is equals to minus 9 over 2. So this is equals to minus 9 over 2. Good. Now we can clear these fractions by a simple cross multiplication. If I cross multiply this, what am I going to get? I'm going to have 4m cubed minus 3m squared, okay, minus 18m, okay, minus 11, okay, equals to 27. Now, where are these values coming from? What I'm basically doing is cancelling out. These two cancels out this 6 here. It becomes 3. So what I really have here is 1 over 3. The bracket equals to minus 9 because the 2 has been cancelled out. Okay, now these exams, they are written. Now, in these exams, you are given limited spaces to solve. So you have to be efficient, make good use of the spaces. So what happens? 3 times minus 9 will give me minus 27. Okay, so finally we could have the polynomial is actually 4m cubed minus 3m squared minus 18m, then we have minus 11 plus 27, okay, which will give us plus 16. Okay, so this is what we have. Everything is equal to 6. So all we need to do is to find the integer solution for this polynomial. So we can do that using the factor theorem. Now let's look at this polynomial. We can test some factors. Okay, but before we do that, the factor theorem tells us that any integer root of the equations must be a factor of the constant term divided by a factor of the leading coefficient. Okay, so this is a constant term, 16, and the coefficient of this is the constant term, and this is the leading coefficient. Okay, so I repeat, it says that any integer root of the equations must be a factor of the constant term divided by a factor of the leading coefficient. Now the first thing we do is to try out some factors to see if there is one that we can substitute gives us 0. Okay, so that's the first thing. We can try one, a quick check for 1. This gives us 4 minus 3 minus 18. It's not going to cancel. Okay, so I'm going to try F2. So let me try F2 for instance. Okay, now for F2, okay, I'm changing my pen. So I'm going to try F2. Let's try F2. So we have F2 equals to have 4, 2 raised to power 3, that's 4m squared, minus 3, 2 squared, minus 18, 2 plus 16. Okay, so basically I'm having 2 raised to power 3 is 8. 4 times 8 gives me 32. 2 squared is 4 times 3 is minus 12. Minus 18 times 2 gives me minus 36. And of course, plus 16. So we end up having 32 plus 16 gives me 48. 12 plus 36 is 48. 48 minus 48 is 0. So it means that m equals to 2 is the required integer solution. Okay, that is an integer. So definitely that's a required integer solution. Now you will ask, are we not going to carry out a long division to find the other factors? Now let's do a check on this question. Let's attempt to completely find the roots of this polynomial. Okay, this is not required, so I'm going to just write check. Let's do a check to see if we stopped abruptly. So I have here 4m squared minus 4m cubed rather, okay, minus 18m plus 16. Okay, so let's see. So I have 4m cubed minus 3m squared minus 18m plus 16. Okay, so 2 is a factor, so we'll do m minus 2. This will give me 4m squared. No, the drill, use it to multiply. This becomes 4m cubed. Okay, then do 4m squared times minus 2 gives us minus 8m squared. Okay, so the next thing now is we subtract at that level. Okay, so let's see. Okay, so this is 0. Here I'm going to have minus 3m squared minus 8m squared. Okay, and that will give me 5m squared. So we're going to have 5m squared. Okay, to bring down this minus 18m plus 16. Good. So this is a quadratic expression which we test for the possibility that it is factorizable. Now, a quick check on this quadratic equation, we quickly find that this is not factorizable. Okay, which lays validity to our initial solution that the only integer solution for this question is 2. So therefore, m equals to 2 is the required solution. Good. Now, question 2, we are asked to solve these logarithms. So first thing first, we open up that bracket. This is 2 log x a minus 2 is equals to log x. So CLT, I'm going to collect like terms. If I collect like terms, I'm going to have 2 log x minus log x equals to 2. So basically, So we know that this is to base 3. So I'm going to have log x to base 3 is equals to 2. Good. From the definition of logarithm, this implies that x is equals to 3 squared. So therefore, x is equals to 9. Okay, the question says we should solve the two simultaneously. So we've obtained what x is. So it's easy. What we'll do next is simply we come here, we see that y is equals to root x plus 1. This is given. Since we already know the value for x, then we substitute. So this gives us y is equals to root 9 plus 1, which is 3 plus 1. Therefore, we see that y is equals to 4. Okay, so we have our solutions. Therefore, y is equals to 9, 4. So these are the solutions to this set of equations. Question 10, given that 8 combination x, 7 combination x, and 7/6 bracket 6 combination x forms the first 3 consecutive terms of an exponential sequence, we are required to find the value of x. Now, since it's an exponential sequence, we know that it has the same common ratio. However, there's a very important result we need to be aware of. This. Okay, let's say we have a sequence. Okay, let's look at it. Let's say we have a sequence 2, 4, 8, 16, 12. Now, this is an exponential sequence. How do I know? Because I know that the common ratio is 2. 4/2 is 16. Okay, so I'll write that properly. So we're going to see that the common ratio is 2. But there's a very interesting property we need to be aware of. Now let's take the second term for instance. A T2 is T2 is 4. Now, if we square it, 4 squared is equals to 16. Now, let's multiply the first and the third term. So if we multiply this, that is T1 times T3, we get 2 times 8, which gives us the same thing, 16. So it is true that the square of the middle term is always equal to the multiplication of the term that comes before it and that comes after it. I'm going to use this very interesting property to reduce the difficulty of this question, solve it in such a way that it will not be too complicated. Now, the first thing I need to do is, first of all, we need to write 8. Need to write 8 combination x. 8 combination x be written as 8/8 minus x, 7 combination x. Okay. Now we can also say 7 combination x is equals to 7/7 minus x. Okay, then 6 combination x. Okay. Now we can let's call this equation 1 and we call this equation 2. I can transform equation 2. Okay, so from 2, from equation 2, I can write this combination x is equals to 7 minus x, okay, over 7. Then here we have 7 combination x. So effectively, I just made 6 combination x the subject of the formula. Now, let's go back to this very important result here. What I just said here is that t2 squared equals t1 times t3. Now, this result is obtainable for any of this. I can say, okay, a square is the same thing as 4 times 16, which is true. A square is 64. 4 times 16 is 64 also. So basically, I'm going to use this expression. Now, in the original question, the second term is 7 combination x. So I'm going to say this implies that 7 combination x, okay, equals to T1. What is our T1? Our T1 is 8 combination x. So this is 8 combination x times 7 T3. So basically, this is my T2, this is T3, and this is T1. Okay, so this will be 7 over 6 this combination x. So I will need to make a substitution here. Okay, so that's the trick. I need to make a substitution. I want us to focus on what I'm doing here. Okay, so let's look at this box I have here. That is the key to solving this question. Good. So remember, it is squared. 7 combination x squared. Okay, so this will give me 7 combination x bracket square. Then I will make the substitutions I have here. So 8 combination x is basically 8 over 8 minus x, okay, multiply by 7 combination x. So we've written that. Then times 7 over 6, okay, times 7 over 6, 6 combination x. Now, what is 6 combination x? 6 combination x from equation 3 is basically 7 minus x. So this is 7 minus x. Let's put it in brackets, neatly expressed, over 7. Okay, then we'll have times 7 combination x. Okay, so I take that again. So what I'm basically doing is I'm following this equation I have here. 7 combination x squared is equals to 8 combination x. We made that substitution. Then 7 over 6, look at it, 6 combination x is this. So we've written it. So at this point, we can easily cancel. Okay, so what do we do here? We see that 7 cancel 7. Okay, we can cancel this 7 combination x. So I can cancel this, and this one remains just 7 combination x. Okay, so we are here. So what do? We can reduce this to 1 equals to, okay, why is it 1? Because if I divide through with 7 combination x, one of these will go. Okay, if I divide again by the remaining 7 combination x, the second one will go. So what's going on there is that this one gets cancelled out completely. This one goes, this one goes. 7 combination x times 7 combination x is 7 combination x squared. So they're going to cancel themselves on both sides. Okay, then we see that let's see what else we can do there. Okay, so 7 over 6, this cancels this effectively. 2 here is 3 and 2 here is 4. So it reduces to 4. You open your bracket. 7 minus x divided by 3, 8 minus x. Okay, so let's continue here. So if we cross multiply this will come out 3 times 8 is 24. 24, so this will be 24 minus 3x. Everything will be multiplied by 1, it changes nothing. Then the right hand side, 4 times 7 is 28. Okay, then 4 times minus x gives us minus 4x. So we collect like terms. Now, if we collect like terms, what do we see here? This is going to be minus 3x plus 4x is equals to 28 minus 24. Okay. So we see therefore that x is equals to 4. And this is the solution to that question. Now the B part, that is 10B, it says we should find the common ratio of the sequence. Now the common ratio is easy. We know that R is, let's take T2 over T1. Okay, T2 over T1. Now what is our T2? Our T2 is 7 combination x, so that's saying 7 combination x divided by 8 combination x, which we found already to be 7 combination 4 divided by 8 combination 4. So we continue here. R will now be, now what is 7 combination 4? Okay, this is the same thing as saying 7 factorial divided by 7 minus 4 factorial. Okay, then you have 4 factorial. Let's put them in brackets and express it neatly. Divided by 8 factorial over 8 minus 4 factorial. Then you have 4 factorial. So let's see what this gives us. So basically this will be and simplify that. Okay, so it will be 7 times 5. Okay, 7 times 6 times 5. 7 times 6 times 5, because everything 4 factorial will be cleared by this 4 factorial divided by 3 factorial. Okay, so this gives us 8 times 7 times 6. Okay, everything divided by 8 minus 4. Okay, I think we get to 5 here. Okay, so everything divided by 4 factorial. So 4 factorial is the same thing as, so first of all, you can put 4 factorial, but for the sake of our space here, I can replace 4 factorial by its true meaning, which is 4 times 3 times 2 times 1. Okay, now the same thing is obtainable here. I can replace 3 factorial with 3 times 2 times 1. So basically this cancels this. Okay, 8 goes away. Let me use the pen I use for canceling. 8 goes away with this 8 here. Okay, then 3 cancels 6, making it 2. So we've already found that. Now all of these you can actually use your calculator to Now, in all of these, you can actually use your calculator, but it's a theory paper. You have to show some steps of how you are obtaining your answer. So here I have 7 times 5, which is 35, divided by Here we have 7 times 2, which is 14. 14 times 5 gives us 70. Okay, so we have 70 here, which is 1/2. So we see that the common ratio of the sequence is half. Good. Now, the sum of the first 10 terms of the sequence. Now, because the common ratio is less than 1, we're going to use the formula xn is equals to a, the open bracket, 1 minus r raised to power n divided by 1 minus r. So that's the formula we're going to use, where our a, our first term, which is 7 combination x, a is equals to, so we see that a is equals to 35, n is equals to 10, and r equals to half. Okay, so all we need to do here is simply to fix in these values, and that will give us the sum of the first 10 terms. Good. So 35, 1 minus half raised to power 10. Okay, let me use square brackets for the outer one. Okay, everything divided by 1 minus half. Okay, so what do I have here? 35. 1 minus 1 over 2 raised to power 10. That's 1024. Okay, yes. So we have 1024. Everything divided by the denominator. Now let's solve the denominator. The LCM here is 2, so I'm going to have it's going to be 1 minus half, which is half. It's still divided by half. Good. So here we simplify. It's going to now be 35. 1024 minus 1 over 1024, okay, divided by half, which I can flip to be 2 over 1. So I'm going to have 35, 1023, everything, 1024 divided by 2, we're going to get 512. Okay, so this is 512. So we've obtained our solution to this question. Okay, so therefore x10, sum of the first 10 terms, okay, is equals to 35 times 1023. Let's quickly evaluate that. Times 35, which is 35,840, 35,840 divided by 512. Final answer, we get 70. Okay, so this is the solution. The sum of the first 10 terms of that sequence is 70. Question 11a, express 4 plus root 7 over 4 minus root 7 close bracket squared minus 4 minus root 7 over 4 plus root 7 bracket squared in the form p plus q root 7, where p and q are real numbers. So we must be observant. This is squared, this is squared, so this is a difference of 2 squared. Now we'll recall that for difference of 2 squares, a square minus b square is the same thing as a plus b, a minus b. This is a difference of 2 squares. Okay, now this is the idea that we're going to use. So I'm going to make a is equals to 4 plus root 7 over 4 minus root 7. Now, we need to rationalize the denominator. So how do I do that? I simply multiply the numerator and the denominator by the conjugate of the denominator. So instead of minus becomes plus. We've not changed this expression. This only allows us to simplify it because I'm just multiplying by 1 effectively. Okay, so we have plus root 7. Good. So let's see what happens here. So 4 times 4, let's enclose in brackets for simplicity. So 4 times 4 is 16. So this is 16. 4 times root 7 is 4 root 7. Okay, root 7 times 4 is the same thing. 4 root 7. And lastly, root 7 times root 7 will come out as 7. Okay, everything divided by the denominator here, which will now be 16 minus 7. Because this is the conjugate, we are multiplying by the conjugate. All it means is that we square the first term, 4 squared, then we square the second term, root 7 squared. So it will reduce to this. Now let's collect the like terms here. 16 plus 7 is 23. Okay, 4 root 7 plus 4 root 7 will get 8 root 7. So this is 8 root 7. Everything divided by 9. We keep this. Now for B is 4 minus root 7 divided by 4 plus root 7. So again, I'm going to do the same thing I did for A. I multiply by its conjugate. So this gives me 4 minus root 7 divided by 4 minus root 7. And let's see what we have here. Okay. Now 16, 4 times 4 is 16. This is minus 4 root 7. Okay, minus root 7 times 4. Simply expanding the numerator. Then lastly, we are going to have minus root 7 times minus root 7, which gives us plus 7. Okay, everything divided by 4 squared minus root 7 squared, giving us 16 minus 7. 16 minus 7. So we have 16 minus 7. Okay, so let's see. Again, I'm going to have 23, but this time around it will be minus 8 root 7. Everything divided by 9. So we go back to our original result, which is a square minus b square is this. So this implies that I just need to, so a square is this, so it will now be a square minus b square is a plus b, a minus b. So a is 23. We have 23 plus 8 root 7 divided by 9. That is a, then plus b, of course, we have to add it. That will be plus 23 minus 8 root 7 by 9. So this is my a plus b. Let's keep it. Then we need to multiply it by a minus b. So a minus b, I'm going to have 23 plus 8 root 7, okay, over 9 minus, okay, since it's a subtraction, okay, what's going to happen is that this becomes minus 23, while this one becomes 8 plus 8 root 7. Okay, so this becomes, because the negative sign here, okay, now this is what's going on here. This negative sign here minus b makes this one to be negative and makes minus 8 through 7 to become positive. So it becomes 8 through 7 over 9. Okay, now this is what we have here now. Okay, so what do we do next? The LCM here is the same, so that is 9. So 23 plus 23 gives me 46. So I'm going to have 46 over 9. Why? Because 8 through 7 minus 8 through 7 will cancel out. The denominators are the same. So the first parenthesis ends up at 46 times 46 over 9. Then we open the second one. 23 minus 23, it disappears. Okay, so that is that goes away. Okay, so here becomes 8 through 7 plus 8 through 7. I'm going to have 16 root 7 over 9. Okay, so this question is solved. All we need to do is to say, okay, 46 times 16, let's see what happens. 46 times 16 gives me 736. So that's 736. So I'm having 736 7 over 81. Okay, so this is our solution. So we are asked to express our final answer in the form p plus q root 7, where p and q are real numbers. So if we make reference to that, it means that therefore p is equals to 0, while q is equals to 736 over 81. Okay, so we'll be looking at question 11b. Two functions f and g are defined on the set of real numbers by fx equals to this and gx equals to this. X is not equals to plus or minus 2 root 2. So we are required to find the domain of it. So first of all, let's write this properly. So I'm going to have fx giving us square root of 16 minus x squared over x squared plus 4. Okay, great. Now we have to look at the denominator. First of all, for this to have a solution, the entire expression fx must be greater than or equals to 0. So we need to examine it. Let's look at the denominator. So looking at the denominator x squared plus 4, we see that the denominator is always positive because whatever real x squared will always be positive. So denominator is always positive for all real x. Okay, so for any real number x, that denominator will always be positive. Now let's examine the numerator. We have 16 minus x squared. Now for the numerator, we observe that 16 minus x squared must always be greater than or equals to 0. Okay, it cannot be less than 0, else it will lead to a complex solution. So this becomes 16 is greater than or equals to x squared, which gives us x squared is less than or equals to 16. Okay, now we take the square root of both sides. This implies that we have x is less than or equals to plus or minus root 16, giving us the final solution. X is equals to minus 4, okay, or x is equals to Now, these solutions are inclusive, okay, because of our initial condition of greater than or equals to 0. So the final solution here will be, we're going to have a range -4 is less than or equals to x, x is less than or equals to 4, okay, of which we can also write as -4 in terms of vectors. Great. So this is the domain of f. Done that. Now GOF. This simply means we need to insert fx into G. So first of all, let's write the function gx. Function gx is x squared minus 4 over 8 minus x squared. So we have s squared minus 4 divided by 8 minus x squared. So this is the required function for gx. Now, we recall that fx is equals to square root of 16 minus x squared, okay, divided by x squared plus 4. So let's look at the expression GOFX. So what are we going to get for GOFX? So let's insert, okay, so this will be fx inside gx. So we're going to have fx squared minus 4 divided by 8 minus x squared. Okay, so that will give us basically 16 minus x squared divided by x squared plus 4. Great. So we're going to insert these values and see what we're going to get. Next step, let's insert fx. So that will give us 16 minus x squared. Since we're squaring this expression, everything comes out and the square root sign clears. Divided by x squared plus 4, okay, minus 4, everything divided by the denominator, 8 minus 16 minus x squared divided by x squared plus 4. Okay, so that's good. So let's solve them separately. For the numerator, we simplify as follows. So I'm going to have 16 minus x squared. Okay, at a go, we see that the LCM here will be x squared plus 4. So I can come here and simply say this is 4 x squared plus 4, everything divided by x squared. So what really did I do here? What I did here was to say, okay, fine, the LCM of x squared plus 4 and 1 is x squared plus 4. So x squared plus 4 into x squared plus 4, that is 1. We multiply by the numerator, nothing changes. 1 into the LCM is x squared plus 4, so to be -4 x squared plus 4. So that's what happens. So we simplify that numerator. Let's see what we get. So I'm going to have 16 minus x squared minus 4x squared minus 16, everything divided by x squared plus 4. So this gives us equals to 16 minus 16 is 0, minus x squared minus 4x squared gives us minus 5x squared divided by that denominator. So that gives us x squared plus 4. Okay, so that's good. Now let's look at the denominator and see what we get. So let's evaluate the denominator and hope this space is enough for us. So for the denominator, I will go at I'll start here. Let me change the pen for clarity. So I will just make here 1. Okay. Then LCM of 1 and S squared plus 4 is S squared plus 4. So basically, I'm going to have this is the denominator here. I have to bring that down a little. Good. So I'm going to have here S squared plus 4. 8 into 1 into the LCM is the LCM itself. So this one opens as 8 goes into S squared plus 4. Okay, that's what we have here. 8 goes into S squared plus 4. Then of course this one remains, this becomes minus 16. Then minus times minus makes this one plus, so plus x squared. Good. So let's open this up. So I'm going to have 8x squared plus 8 times 4 is 32. Okay, minus 16. Okay, plus x squared. Everything divided by x squared plus 4. So we can just get the like terms here. So this gives us 8x squared plus x squared, that is 9x squared. Okay, then we'll have 32 minus 16. So that gives us plus 16. Everything divided by x squared plus 4. Okay, so let's get the final solution. We don't have much space there. So let's see what we can get here. Okay, now all we need to do is to go back to where we started from, that the expression we're looking for is GOFX. The numerator, we've got it as minus 5x squared over x squared plus 4. So if I have minus 5x squared over x squared plus 4, okay, great, divided by what I have here, which is 9x squared plus 16 over x squared plus 4. Now we use our intuition to know that we're going to flip this. This division changes to multiplication. So once that happens, the numerator and the denominator of the fraction will also flip. So I'm going to have this as times. We're going to have this as x squared plus 4 divided by 9x squared plus 16. Okay, so this cancels this. So our final solution is minus 5x squared divided by 9x squared plus 16. So this is our final solution. Okay, so let's go at two statistics and probability. So we'll be looking at these questions. So if the mean and standard deviation of numbers x 2.5, 5y, and 7 are 4 and 31 over 10 respectively, find the values of x and y where x is less than y. So first of all, we're going to use the mean to formulate the first equation. Okay, so we already know that mean x bar is equals to summation of x divided by n. So that's what we're going to use. So this becomes x plus 2.5 plus 4 plus y plus 7 divided by, there are 5 terms there, will give us 4. Okay, so let's add this up quickly. So going to be x plus y plus 4 plus 7 is 11. 11 plus 2.5, 13.5. So this gives us 13.5. Cross multiply this. 5 times 4 is 20. Okay, so this will give us, so this implies, let's make use of our space here, x plus y is equals to 20 minus 13.5, which will give us 6.5. So this forms equation 1. Now we use the standard deviation value to get the equation 2, but we should know that the variance is the square of the standard deviation. So the variance is equals to root 31 over 10 squared. Okay, so that is basically the same thing as 3.1 squared. Okay, so this will give us equals to 3.1. Now we recall that the formula for the variance, is equals to, this is variance, let's not get confused. So the formula for the variance is equals to summation of xi squared divided by n minus the mean squared. So this is what we need to set up here. Okay, so this gives us, have this as equals to okay, so this gives us x squared plus 2.5 squared okay, plus 4 squared okay, plus y squared plus 7 squared, everything divided by 5, okay, minus the mean squared. So that will give us 4 squared. So this is the setup for our variance. Okay, everything is equals to 3.1, remember, okay, because that's the value for the variance. Okay, so let's bring this up. We have so we're going to have here x squared 2.5 squared, that gives us 6.25. Let's place it well so that 6.25. Then also we need to square 4, that is 16. Then y squared, 7 squared is 49. Everything divided by 5 minus 16 is equals to 3.1. So how do we clear the fraction? The smartest thing to do is to multiply through with the denominator. So we can do that and also add up it. Okay, so this is what we have. So I'll rewrite this to be x squared plus 6.25 plus 16 plus 49, that gives us 65, plus y squared equals to 16.1 plus 16 plus 3.1. So we can simply write that to be 19.1, save ourselves this space. Everything is still divided by 5, remember? That this 5 is still there. Now, if we cross multiply this, this is what we are going to get eventually. We are going to have x squared. We will cross multiply this expression, have x squared plus y squared. Now 6.25 plus 65 gives us 71.25. So we'll have 71.25 is equals to, then let's do the multiplication. So we're going to have 5 times 19.1. This gives us 95.5. So this is 95.5. Keep it aside. So this is 95.5. Now finally, we raise this and make it better. So finally, we see that x squared plus y squared is equals to 95.5 minus 71.25. Okay, so if we do that subtraction, minus 71.25, we get 24.25. Okay, so this is 24.25. Okay, so this forms our equation 2. So we have two equations in two unknowns, so we can easily solve this simultaneous equation. So we recall from equation 1, equation 1 says x plus y is equals to 6.5. So I'm going to rewrite equation 1. So that will give me, so rewriting equation 1, I'm going to have x is equals to 6.5 minus y. Okay, I'll call this equation 3. So what's the trick? I need to substitute x into equation 2. So we substitute x into equation 2. Okay, so that's it. So this gives us x squared. So we have 6.5 squared. So watch what I'm doing. I'm substituting x, which is now 6.5 minus y, into equation 2. So instead of writing x squared, I write 6.5. I'm going to write 6.5 minus y, everything is squared, okay, plus y squared, everything gives me 24.25. So this is pretty neat. All we need to do is to expand that. So let's expand and see. So I want to do the expansion here because of space. So if we expand this, we need to say 6.5 squared. So if we say 6.5 squared, we get 42.25. So this is 42.25. Okay, then we do 2 times 6.5 times y. So let's do that for clarity. I'm just following the steps. So that gives us 13. We know that 6 times 2 is 12. 6.5 times 2 gives us 13. So I need to multiply this. This is the first of the expansion. 6.5 times minus y times 2. So this gives me minus 13y. Okay, then finally minus y squared is this, plus y squared. Everything equals to 24.25. So we can basically collect like terms. So this gives us, if we collect like terms, we have y squared, okay, minus 13y, then 24.25 comes to the left hand side, becomes 42. So this will be this minus this. Okay, 42.25 minus 24.25. So we have 42.25 minus 24.25. That gives us 18. So this becomes plus 18 equals to 0. So it ends up as a quadratic equation. So all we need to do is to factorize this quadratic equation. But we missed something. We forgot this y squared. So we should have another y squared here. So let's correct that. Okay, because we had, when we expanded, this became y squared. Then there is another y squared here. So we have another plus y squared. Everything equals to 24.25. So the implication is that this becomes 2y squared. So I'm going to have here as 2y squared. Good. So let's factorize this. Now we know the rule for factorization: 2 times. We're not learning quadratic equation here, so let's quickly factorize. It's going to be 36y squared. So I'm going to use the factors 9 and 4. So this reduces to, this implies we're going to have 2y squared minus 9y minus 4y plus 18 equals to 0. Okay, so let's quickly factorize. So the HCF here is y. So we factor out y. Y becomes y, 2y minus 9. Okay. Then here, the HCF of minus 4y and 18 is minus 2. So this also becomes 2y minus 9. So this is basically factorized. Solutions are y minus 2, 2y minus 9, everything is equals to 0. Okay, so it means that y minus 2 is equals to 0, or 2y minus 9 is equals to 0. Okay, so this implies that y is equals to 2, or y is equals to 9 over 2, which gives us 4.5. So now we recall that from equation 1 is equals to 6.5 minus y. So when y is equals to 2, it implies that this means x is equals to 6.5 minus 2, which gives us 4.5. Okay, now also when y is equals to 4.5, this implies that x is equals to 6.5 minus 4.5, which gives us 2. But the question is very clear. We didn't even need to do that. He said we should find the values of x and y where x is less than y. So if x is less than y, it means that our final solution, based on the condition given to us in this question, are x equals to 2, y is equals to 4.5. So we've obtained the values of x and y for this particular question. Excellent. Now, question 13. An association is made up of 10 journalists and 9 engineers. If a committee of 4 members is to be formed from the association, find the probability that it will consist of at least 2 engineers. Consist of at least 2 engineers. Now, we have 9 engineers. If it will contain at least 2 engineers, it means that we have 2 engineers. We could also have 3 engineers, and we can also have all 4 members of that committee engineers. So in terms of combination for the engineers, that would be, if we have select 2 engineers, it means that we must select 2 journalists. So that would be going to have a for the journalist 10 combination 2 times for the engineers that will be 9 combination 2. Okay, this is one possibility. So another one is also we could have just one journalist, so that will be 10 combination 1 times 9 combination 3, or we could have no journalist at all, so that will be 10 combination 0 times 9 combination 4 for the engineers. Okay, so this involves the all of the possibilities that we can actually get from the conditions set for us here in 13A. Okay, so let's proceed to solve this right away. So for clarity, these blocks are together, this block together, these together. So we'll start with 10 combination 2 times, so we can write this neatly as 10 to times 9 2. If we do that, what do we get? Okay, so this gives us, we have 10 combination 2. 10 combination 2 is 45. So this is 45 times 9 combination 2. 9 combination 2 is 36. So we multiply this to 45 times 36. What do we get? 45 times 36. We get 1620. So this is 1620. Okay, so we are done with that. Now the next one, let's look at 10 combination 1 times 9 combination 3. So what do we get here? 10 combination 1, we get 10. Okay, then 9 combination 3, we get 84. Okay, so 10 times 84 will give us 840. And we have 10 combination 0 multiplying 9 combination 4. 10 combination 0 will give us 1. Times 9 combination 4. 9 combination 4 gives us 126. Good. So we need to, we know that these are mutually exclusive probabilities. So everywhere we see or, we replace it with an addition sign. So we're going to add this and add this. Okay, so this implies that we're going to have 1620 plus 840 plus 126. So let's sum up these and see what we get. Plus 840 plus 126, and that gives us 2586. We'll have this as 2586. Okay, so this is the now, but this is a probability question. This is the favorable outcome. What of the total possible outcomes? Without restriction, okay, so the total outcome without restriction, we know that this will give us is equals to 10 combination 4. Not really 10, because we have to add 10 journalists and 9 engineers, so that will give us 19. So we're going to do 19 combination 4. So if we do that, 19 combination 4, we're going to get 3876. So this is 3876. So the required probability here is basically a probability of at least 2 engineers probability of at least 2 engineers, that is greater than or equals to 2 engineers, will be equals to the favorable, which is all the possibilities we've calculated, 2586 divided by 3876. Okay, so let's compute that. Divided by 3876, and that gives us 0.67 approximately. 0.67 approximately, which is the same thing as 67%. Okay, so let's move over to the second question. It says to find the probability that it will consist, the committee will consist of 75% journalists. So if it will consist of 75% journalists, we know that there are 4 persons in that committee. We're going to do 0.75, okay, times 4. So that tells us there will be 3 journalists in that committee. Okay, so there will be 3 journalists. Now it means that we are looking for 10 combination 3 times the engineers are 9 combination 1 divided by the total probability, which is 10 combination 4. I keep writing 10, it's 19 because the total number of engineers and journalists is 19. So that is 19 combination 4. We've already obtained that 3856. So quickly, this is the same thing as saying 10 combination 3. We have it 10 combination 3 gives 120. Okay, 9 combination 1. 9 combination 1 gives 9. So everything divided by 19 combination 4, which is 3876. Okay. Note that in permutation, if you have something like 10 combination 3, same thing as writing it as 10 3. Different notation, the same meaning. Okay, so this will give us 120 times 9, 1080, divided by 3876. We can decide to reduce this. Those are even numbers, so let's try to make it smaller. So we divide the numerator by 2, we are getting 540. Okay. Then here, this is 19. Okay. To 7 gives us 3 remainder 1, 16, that is 8. So 2 can go again. 540 divided by 2 gives us 270. So let's bring this down here. 270, okay, divided by this. Now 2 into 19 gives us 9 remainder 1. Once 13, 6 remainder 1. 18 is 9. So we're having 969. Okay. Now let's see. We should be able to divide that number by 3. Okay. 3 into 27 is 9. And then we have this is 0. Okay, then denominator 969 divided by 3, we're having 323. So we can keep breaking this down as much as we can. Okay, then let's see, can we still divide by 3 there? So we can leave it here. We'll say your final answer is 90 over 323. Okay, we can leave it also in terms of decimals. So that will give us 90 Now let's see if our reduction is correct. If it's correct, we should have the same answer. 90 divided by 323 gives us 0.28 approximately. Then the original thing was 10 divided by 3876. Okay, so it's correct. 0.28 approximately is the probability. So that's the answer. Now C says we should find the odd number of engineers. So it means that we can either have 9 combination 1. Okay, one engineer was selected, and we have 3 journalists selected. We could have the situation where we have 3 journalists selected, so 9 combination 3, and just 1 journalist selected. So these are the possibilities. Okay, so let's look at it. Now remember, it's probability. We are still dividing by the total probability for the total possible outcome, which is 19 combination 4. So let's go 9 combination 1. So basically, we have some space. Let me express this better. So everything here will be divided by 19 combination 4. Okay, I'm using this notation because of our space. Okay, ideally you should be consistent with your notations. So 9 combination 1 we are going to get 9. So that gives us 9 times 10 combination 3, 120. Okay, or we change that to addition. Then we have 9 combination 3. 9 combination 3 gives us 84. So this is 84. Okay, times 10 combination 1, which is 10. So everything divided by 19 combination 4, which we know to be 3876. That one has not changed throughout the solution here. Okay, so 120 times 9, we have 1080 plus 840. I actually solved this question before, divided by 3876. Okay, so we get this to be so basically this is 0. 4 plus 8, we have 12. 8 plus 1, 9. 1920 divided by 3876. Okay, we could reduce this as much as we can, and if we attempt to do that easy, we can simply say 1920 divided by 2, that gives us 960. Okay, then here the denominator, I'm having 19. I've done this before. Then this is 3, this is 8. Okay, so we divide again by 2. We're going to have 4 remainder 1. So this is 480 divided by, we're going to have 9 remainder 1. This is 6, 9. Okay, so basically I don't think we can go further here. This is even. So we can just simply write our final answer as a decimal. So let's see. If we do 1920 divided by 3876, we get 0. So this is basically 0.5. 0.5, which is what we'll also get if we use the final simplification. 480 divided by 969. Okay, so this is it. We'll solve this question entirely. Okay, question 14. Okay, question 14. 5 forces acting on a particle are represented by these vectors. Okay, where P, Q are real numbers. Okay, if the particle is in equilibrium, we are required to find the values of P and Q. Now, what do? We observe that if this system is equilibrium, then it means that the horizontal forces add up to 0 and the vertical forces add up to 0 also. So we're going to do exactly that. So for the horizontal forces, these are the horizontal forces, the I values, this and this and this. So I'm going to say horizontal forces equals 0. Okay, so I'm going to have 2 plus 4 plus the coefficient of I there is 1. Okay, I missed 1, I missed -5. So let's capture that. Let's write it in sequence. The 2 plus 4 minus 5. 2 plus 4 minus 5. 1 plus P, everything equals to 0. Okay, so this is 6 plus 1, 7. 7 minus 5 is 2. So I'm going to have 2 plus P equals to 0, which implies that P is equals to -2. So we do the same thing for the vertical forces. Vertical forces, which are the J values, we add up to 0 also because the system is in equilibrium. So vertical forces equals to 0. I'm going to have 3J, 3 basically, minus 7 plus 8. Okay, then coefficient of J here is 1. Okay, plus 1 plus Q, everything adds up to 0. So for our vertical values, these are the ones in green. Okay, these are our vertical values. So what do we do here? We simply collect like terms like before. 3 plus 8 is 11. 12 minus 7 gives us 5. Okay, so it becomes 5 plus Q is equals to 0. Therefore, we see that Q is equals to -5. So we have found that already. Okay. Now let's look at 14b. WXYZ is a parallelogram whose vertices are this. We are required to find the values of M and N respectively. Okay, let's see if we can get a parallelogram from these shapes. Okay, it doesn't really matter whether the parallelogram behaves much like a rectangle. So if we say this is a parallelogram and we label consistently, I'm going to label in an anti-clockwise sense. So WXYZ. Okay. Now let's get the coordinates. Here, the coordinates of this point, this vertex is -1, 1. Okay, so we can write it here, -1, 1. X is MN. Don't know those values. Okay, then Y is 5 minus 7. Then we have Z is 2, 4. Z is 2, 4. Good. So we are required to find the values of M and N. Okay, so let's go. Now, what do we know about a parallelogram? We know that the opposite sides are equal. So basically, this side is equal to this side, and this side is equal to this side. So we're going to use that fact to solve this. Okay, so taking the X value, I will say M. So this side, I'm going to equate this side to this side. So M, okay, minus 5, that's the length of the breadth or the width of this parallelogram, is equals to, here we're going to have minus 1 minus 2. So I'm going to have minus 1 minus 2. Okay, so basically this becomes m is equals to 5 minus 3. M is equals to 2. It's as simple as that. So we compare also for the other coordinate, the y coordinate. So that will give us n minus 7 is equals to 1 minus 4. We're comparing similar values. Okay, so this like these are Cartesian coordinates. The first one is x value. So we compared m and 5 as with minus 1 and 2. So I'm comparing n minus 7, which is the length of this, with the y coordinate of the length here also. That will be 1 minus 4. So basically, I'm going to have the n plus 7 is equals to minus 3. So n is equals to minus 7 minus 3. So n is equals to negative 10. So therefore, see that m is equals to 2, n is equals to minus 10. Okay, so that's great. Now the last one, so we should find the unit vector in the direction of xy. First of all, where is xy? Xy is this part. Okay, so for x we have 2 minus 10. Okay, so x is 2 minus 10, and for y we have 5 minus 7. Okay, so the unit vector we require will be the addition of those two vectors. It will be equals to xy divided by the modulus of xy. So let's first of all find xy. Okay, the formula, we need to do some things before we can write this formula. So I'm going to call this one x1, here is y1, x2, and here is y2. Okay, now so I'm going to have x2 minus x1, okay, plus y2 minus y1. So it's going to give us 5 minus 2. Okay, of course, this is the I coordinate and this is the J coordinate. We must not lose track of that. I is plus y2 is negative 7, so that will be negative 7, negative 10. Okay, then we'll have our J. So this comes out as 3i. Okay, now what's going to happen here? We're going to have minus 7 plus 10. Negative becomes positive, so that will be plus 3i plus 3j. So that's what we're going to have. Okay. Now let's find the modulus of this vector. So if we want to find the modulus of xy, it simply means square root of because basically, let's write the formula. So I'm going to have SI squared plus YJ squared. So what do we get here? We get 3 squared plus 3 squared. So that gives us 9 plus 9, which is equals to root 18. Okay, remember we can factor this to be in terms of solve 9 times 2, which finally gives us 3 root 2. So it means that our unit vector is basically 3i plus 3j divided by 3 root 2. We can separate this, becomes 3i over 3 root 2 plus 3j over 3 root 2. Okay, So basically, I'm going to have 1 over 2 I plus 1 over root 2 b. So there are many things we can do here. We can decide to rationalize and get a simpler answer. But it's okay, it's sufficient. I think we get the idea at this point. Question 15. An object is thrown vertically upwards on the top of a building 20 meters high. If the object passes the point it was thrown after 4 seconds on its way down, find the velocity at which it was thrown. So we need to understand this question. Let's say we have building. This is okay. So basically, let me use this to illustrate it. This is the top of the building. Okay, so this is the top. Okay, so basically the base of the building is somewhere around here. Okay, very well. Now they are telling us that the building is 20 meters high. So the building is 20 meters high. You get it here. So here is 20 meters. Good. Now it got to a certain height. We don't know what it is yet. Not a problem. So what do we know first? We know that it got to this point. Let's designate it point P, and it started falling back. Now, as at the point it passed the point of projection, this is the point of projection. It has already spent 4 seconds in flight. Now, from our understanding of projectile motion, that means it's used 2 seconds to get to the top and 2 seconds to come down. Okay, so I could say T is equals to 2 seconds to get to the maximum height here. We don't know what that maximum height is for now. Then we know that acceleration due to gravity g is equals to 10 meters per second squared. Okay, now what's the question they say we should solve? They say we should find the velocity at which it was thrown. So we know u, we know t, we know acceleration due to gravity. We also know that at this maximum height, okay, we know that at this maximum height h, the final velocity is equals to 0. So we have our 4 parameters. We look for the equation of motion that connects these parameters. So I will say okay, so we'll use the relevant equation of motion. Okay, considering the parameters we have t is equals to 2 seconds, g is equals to 10 meters per second squared, and then p, the final velocity, is 0 meters per second. So I will use v is equals to u minus at. Why is it negative? Because at the point of projection, we are opposing gravity. Okay, so this becomes v is equals to u minus gt. Okay, the final velocity is 0. We substitute. So this is what we are looking for, minus 10 times 2. So we have 0 is equals to u minus 20. Therefore, initial velocity u is equals to 20 meters per second, and that is the answer. Now, the second question says we should find the time taken when the object is 10 meters above the level it was thrown. So what do we do here? Let's state our parameters. Now we know the initial velocity u is equals to 20 meters per second. We know that a, acceleration due to gravity, which is equals to g, is equals to 10 meters per second square. Now we see that the height is equals to 10 meters from the point of projection. Now we are looking for the time it takes to get to that height of 10 meters. Good. So we're going to use the usually when you are using the equation of motion, you look for the equation that has the 4 parameters of concern. Of course, one of the parameters is unknown. In that case, that's time. I'm going to use x is equals to ut minus half at squared, but this is motion under gravity, so we'll replace it with s is equals to ut minus half at squared. And of course, the reason by making that negative is that the upward motion is opposing gravity, so that takes a negative value. Okay, so let's substitute what we have. We have 10 is equals to 20 times t, that's 20t minus half times 10 times t squared. So 2 cancels 10 makes it 5. So we are getting 10 is equals to 20t minus 5t squared. So this is obviously a quadratic equation. We rearrange it, it becomes 5t squared minus 20t plus 10 is equals to 0. We divide through by 5 to get smaller values. So it gives us t squared minus 20 divided by 5 gives us 40. 10 divided by 5 is 2 is equals to 0. So this is the quadratic equation. Initially, we're going to attempt to factorize this quadratic equation, but we see that this is not factorizable. Okay, so we're going to use the quadratic formula. I will recall that the formula says, in this case, t is equals to minus b plus or minus b squared minus 4ac, everything divided by 2a. So we substitute those values. Let's see what we get. Our b is minus 4. Okay, so that becomes 4. Minus minus makes it 4. I'm just substituting plus or minus. Okay, because clearly we see from here that in this formula, our a is equals to t. Our b is equals to negative 4, and our c is equals to 2. Okay, so that's how we get these values. So we're just substituting. The formula is negative b, but b is already minus 4, so minus minus makes it plus. So I'll open this up. Have b squared, that is minus 4 squared. Okay, the square of a negative number ends up as positive. This gives me 16 minus 4ac, that is 4 times 1. A is 1, 4ac. A is 1, not t. Always the coefficient. So that is 4 times 1 times 2, which gives us 8. Everything divided. I'm just trying to make do of this little space we have here. That gives us 2. Okay. Now let's finish this off. So clearly that will give us t is equals to 4 plus or minus root 8 over 2. Okay. Then we simplify this by solves. This is the same thing as 4 plus 2 root 2 divided by 2. Now, how did I do this? We express root 8 as a product of two surds, of which one is a perfect square. That's 4 times 2. Okay, the square root of 4 is 2, so that's why I have 4 plus 2 root 2. So this reduces, remember it's plus or minus, two solutions. So this reduces to t is equals to 2 plus or minus root 2. So we have two sets of solution. The first is t is equals to 2 plus root 2. Then we also have t is equals to 2 minus root 2. Okay, so in terms of decimal, we can simplify this to get our final answer. Okay, so basically root 2, we have 2 plus root 2, that gives us 3.41. This is 3.41 seconds. Then here, 2 minus root 2, we have 1.41 seconds. So we see how this works. So how do we interpret this solution? It means that this is when it's going upwards. Okay, the time at this distance of 10 meters where it was projected initially. Then when it falls through that point of 10 meters height when coming down, the total time to get to maximum point and fall down 10 meters is what we are referring to, is what this answer is pointing to. So this is when it's coming downwards. Okay, so these are the solutions. Okay, so in this context, this is the most appropriate because they are referring to when the time at 10 meters during the upward projection. Okay, now the next question is the time taken when the object is 10 meters below the level it was thrown. It's 10 meters below the level it was thrown. So what do we do in this particular question? Let's get our data. Now, from this point, we need to get something. It's 10 meters below the level it was thrown. So we already know that here is this point, here is 20 meters. Okay, then we need to get the maximum height. We need to get the maximum height for this point of projection. So how do we get the maximum height? I'm going to use the relevant equation of motion. So let's go right into it. So first of all, we know that at maximum height, okay, the final velocity is 0. So v is equals to 0 meters per second. Initial velocity remains 20 meters per second. Okay. Then we know that acceleration due to gravity is equals to 10 meters per second square at that point. Now we are looking for x. X is unknown. Okay, now let's illustrate it. It was projected from this point with a velocity u of equals to 20 meters per second. This is the velocity of projection. Now, by the time the object gets to the maximum height h, its final velocity is 0 meters per second. Okay, so we are calculating the height from this point to this point. This is what we are calculating now. We want to know this height. That's the maximum height x. Okay, so we get back here. We can recall that when we recall that v square is equals to u square minus 2as. Okay, so already the final velocity is 0, so this is basically 2ax is equals to u square. We substitute 2 times 10 is equals to 20 square. Okay, so we have 20x equals to 400, giving us as x is equals to 400 over 20, which is equals to 20 meters. So this is quite interesting. So basically, from this point, this x, from this point to this point is also 20 meters. So basically telling us that the full height from here to here is actually 40. Okay, because it's the projection, the object was thrown upwards from a height of 20 meters. Okay, if we add the 20 from that height to the maximum point, it means that everything from the top to the bottom is 40 meters. And let's see, the question is telling us that the time taken when the object is 10 meters below the level it was thrown. So if we get to our diagram, that is around this point. Okay, so this is what happens. It was thrown here 20 meters up, it now falls to a height 10 meters below its point of projection, basically telling us that so we're going to have here is 10 meters plus 20 meters tells us that from here, the point 10 meters below is point of projection to the maximum height, that is actually 30 meters. So we'll be using these facts to solve this question. It's not a difficult question. We just have to logically look at it. Okay. So let's finish this off. We've taken so much time dancing around this. So let's finish. So what do I have? X is equals to 30 meters. Okay. The acceleration due to gravity now, since it's coming down, should be positive 10 meters per second squared. Initial velocity is 0. Initial velocity u is equals to 0 meters per second. Why is it so? Because I'm considering the downward motion in this instance. Okay, since I'm considering the downward motion, okay, from this point here, this velocity, v is equals to 0. This is for the point of projection when it was projected initially to the maximum height. V was equals to 0. Now, when it started falling time, when it started, now when the object started falling down, u will be equals to 0 also. So the downward motion, u is equals to 0. Meanwhile, for the upward projection, v, the final velocity, is equals to 0. So I'm using u is equals to 0 because for this particular calculation, I'm considering the downward fall of this object. Okay, so that's why u is equals to 0. Now we are looking for the time it takes to get to that height of 30 meters falling down. So the time is unknown. So easy, all we need to do is to recall that x is equals to ut plus half gt squared. Now, since the initial velocity is 0, 0 times t will be equals to 0, so this reduces to x is equals to half gt squared. Okay, so that gives us 30 is equals to half times 10 times t squared. Okay, great. So 2 cancels 10 makes it 5. We have 30 is equals to 5t squared, which gives us t squared is equals to 30 over 5. Okay, t squared is equals to 6, which implies that t is equals to the square root of 6, which gives us 2.45 approximately. Let's confirm that. Root 6 is 2.449, so that's 2.5 seconds positive. Good, good, good. Now, so this is what it means. Let's get back to our diagram. It means, let me change the pen. So what it means is this. It took 2 seconds to go from the point of projection to the maximum height. Then when we got to the maximum height, it took 2.45 seconds to come down to this point 10 meters below this point of projection. Okay, so the object spent 2 seconds going to the maximum height, and from the maximum height to a point 10 meters below the 20-meter height of projection, that was 2.45 seconds, just like we calculated now. So it means that the time taken for the object to fall below 10 meters will now be the total time. In this context will be the time for going up and the time for falling to a point 10 meters below its point of projection. So that gives us it's 2.45, not 2.5. So write that properly. This is 2.45. Okay. This is also 2.45. So therefore, we see that T is 4.45 seconds. That's how we solve. So it's just for us to understand this motion under gravity. Once you have a good understanding of what is going on, we can always use the right equation to solve what we want to solve, or what they want us to solve. Okay, so the last question, let's look at the velocity with which the object hits the ground. Okay, now considering from the maximum height, maybe I need to redraw this here for clarity. So we have this. Remember that this height is the velocity with which the body hits the ground. The velocity with which the body hits the ground. Good. Now I'm going to make here. Remember, from the top to the bottom, we have 20 meters to the maximum height. Meanwhile, the point of projection was from 20 meters. So it means that the full height here is 40. So x is equals to 40. That's the height there. So we're going to have here to be x is equals to 40 meters. U is equals to 0 meters per second. Okay. A, acceleration due to gravity, is equals to 10 meters per second square. Okay, so this is what we have here. So the correct equation we're going to use, since we are looking for v is unknown. Okay, now the velocity at this point is v. Velocity is going to use to hit the ground. I'm going to say, we recall that v square is equals to u square plus 2as, because we are working with gravity now. Now this reduces to v square is equals to u square is 0, so that will be 0 square plus 2 times 10 times 40. Okay, so that gives us 2 times 10 is 20, 20 times 40 gives us 800. So v square is equals to 800. Okay, in terms of source, we can break it down. This is same thing as saying 100 times 8. Okay, we can actually get our answers directly from here. We don't need to. Okay, so basically, if I want to solve this, like this becomes 10 root 8. Okay, and that's, I could still break this one down. This is the same thing as 10 root 4 times 2. Okay, so that comes out as 20 root 2. I don't think there's any point doing this actually. We could just because we need to take the square root of both sides, so everything will still reduce at the end of the day. Okay, so I would rather come here and say this point b is equals to root 800. Okay, therefore the velocity with which it will hit the ground will be root 800, which is 28.3 meters per second. 28.3 meters per second. So we really didn't need this part. It was just unnecessary work. We have just from here and gotten our answer. Okay, so this brings us to the end of the 2025 WAEC Further Mathematics paper.
Okay, so this brings us to the end of this solution set. Kindly like, share, and subscribe.